Hello everyone, welcome to my channel. So today we are going to do the code weekly challenge third question, minimize XOR. So let us first take this question, means let us read this question, then about the constraints, and then we will be going at what is being required to do this question. So given two positive integers nums1 and nums2, find the integer x such that x has the same number of set bits as nums2 and the value x XOR num1 is minimal. So these are the two conditions which we are required to satisfy for the x, and that x would be our answer. So note that XOR is the bitwise XOR operation. Basically what they mean by XOR here is that standard XOR, which is basically that bitwise XOR operation. So that they want to say. And then we are required to return the integer x. The test cases are generated such that x is uniquely determined. That is, it would be like that there's no duplicates which would be there. There will be always a unique x, means unique answer would always be generated. The number of set bits of an integer is a number of ones in the binary representation. Basically, they are just conveying that what exactly set bit means to them. So that's the thing. Now comes the next part about the example what they have given to us. So basically here they have given 3 and 5. So here the thing is that binary representation of num1 and num2 is 0011 and 0101 respectively. The integer 3 has the same number of bits set as num2 because here you can easily see that here also 2 bits are set and here also 2 bits are set, right? So first condition is satisfied. And then when we do XOR of 3 with 3, then answer would be 0. So it is the minimal, right? So that's why 3 itself is the answer. Then when we go for this one, so here, this is a representation of 1, representation of 12. So first thing which we are required to do is create a number whose bits are basically, 2 bits are basically set. So in that context only, now we would be going ahead. In that context only, we will be going ahead, right? So when we go ahead in that context, then we figure out that that number is basically 3. And that 3 is that number. If we do XOR with 1, then 2 is the number which we get, and that is the minimum answer which we will be getting. So here the things are like this. But from these examples also, we are not able to get that how it is required to be done. So let us first take that constraint that num1 and num2 can go up to 10 raised to power 9. So that's the thing. Now the thing is that if it can go till 10 raised to power 9, so we can do bit manipulation in such a manner that we can generate this number. So that's the thing. Now, before going to the coding part, let me explain you some concepts and few points which will be helping you to solve this question. So let us head over the explanation now. So for that, first thing is that what rules we are required to follow for getting our answer. So answer should follow following condition. First thing is that set bit should be equal, means the set bits of the nums2 should be equal to the set bits of the answer. Basically, the count of the set bits which are being there in nums2, that should be equal to the count of set bits in our answer. This is the first rule. And then answer XOR with num1 should be minimum. So corresponding to these two things, we are required to figure out with our answer. Now, next thing, how we can go ahead with all that thing. So first thing would be that we require to set it count of num2. Basically, whatever count is there for the number of bits which are set in nums2, that is the thing we are required to store. And then we require to set bits in answer as per the count of num2 set bit. So this is the second thing which we are required to do. So both of these things only, they will satisfy this first condition for our answer. Now next thing, that for minimizing. So for minimizing, we are required to check first for the property of XOR because it is required to be minimized as per the XOR property. Basically, answer XOR to the num1 should be minimum. That's the criteria which is required, right? So first, we will check the XOR property. X XOR with X means same number XOR with same number, that is 0. 1 XOR with 1 is 0. 0 XOR with 0 is 0. But if you do XOR of 1 with 0, it's 1, 0 with 1, it's 1, right? So now here the thing is that we are required to make that answer either equal to nums1 or something which is nearer to nums1. So in that context, we are required to move ahead. So when number is same, then it is the minimum. That is the thing which we concluded from these properties. Now, thus try to set all those bits of the answer which are set in nums1. So this is the first thing which we are required to do. Basically, first thing was that we are required to go ahead with setting all the bits in the answer. Means total bits set in the answer should be equal to the total bits which are set in the nums2. And for nums1, as we require the XOR of both answer and num1 to be minimum, so in that context, we will be trying to set all the bits which are set in the num1 so that we could cancel out all of them. Now, in that also, two further criteria are being generated. So, in that context only, how we are required to set those bits. First thing, for minimizing, start setting bits from maximum set bit rather than LSB. Now, why this is the reason? Basically, we are nullifying the contribution of MSD. How we are doing so? That we are nullifying them, right? So, if by chance our number of bits which are set in num1 are not equal to num2, then surely we are required to set more bits, right? So rather than setting those bits from the MSB side, let us set those bits from the LSB side. But before that, because we want our minimum answer, so we will be setting all those bits which are already set in num1. That's the thing which we are doing here, and that's why we are doing this step. And then you still count of set bit according to the num2 is still left, then start setting from the LSB. As bit set in the LSB will contribute to a lower number. So that's the criteria. And these are the whole points which are being required to solve this question. You could either rewind or view this video again, but these are the critical points which are required to solve this questions. So now, here let us first do a dry run, then we will be moving to coding part. So here, num1 equals to 3 and num2 equal to 5. These are the two numbers which are being given to us, right? So num1 could be, means 3 could be written in the bit representation like this, and 5 could be written like this, right? So the bit count, you can see that here this bit is set, this bit is basically 2 bits are set. So that's why the bit count is 2. And the answer, if we start from MSB, first thing is that. So earlier it would be 0, all 0 would be there, right? Then we start setting, we first check, we go to this point, then this point, then this point. Here we figure out that there is one bit set, right? So we set this bit and other bit is 0. That's the thing. Until now, our bit count from 2 to it becomes 1. And then we go ahead and we check that now there is one more bit which is being set in our num1. So we will be setting that bit which was still left. And now it becomes ultimately a 3 because at this point the bit count is also exhausted. So that's our answer here comes out to be 3. So this was first scenario in which basically this is that scenario when our bit count of num1 is equal to bit count of num2. So this is that scenario. Now comes the next scenario when it is unequal. So let us take the second example which was being given. So here you can check that how one we can write in bit representation is like this and 12 could be written like this. So bit count we are having 2 for our num2, right? Now first thing we will be starting from MSD. So when we start from MSD then we check that here there is nothing, nothing, nothing. Means 3 times we check there was nothing so we hadn't set any bit. But at the last we check that there is one bit which is being set, right? So that's why we set this bit. Now it becomes 1. But when we set this bit, the thing was that our bit count is basically 2. But till now we have set just one bit. So that's why there is one bit which is required to be set. So now we can't set any more bit in this particular sequence, right? So now we will be starting a loop again, and now we will be starting from the LSB side. So that's why here now what thing we will be doing is the 001 which was there. Now we will be starting from there, and then we will be checking the first bit which is unset, as this bit was set, right? So we won't be doing anything. But the next bit was unset, right? So that bit we will be setting, and now answer becomes 3, and also the count also becomes 0. So that's why unbit count now got exhausted. So that's why our answer is 3. So that's why in this particular, when num1 is 1 and num2 is 12, then we get our answer as 3. So this is the thing here. So that's the thing which we are doing here. So like this only we are required to implement this question. Basically, first we will be checking that what is the bit count in num2. Basically the set bit count. Then we will be checking that whatever nums2 bit count is there, according to that, we will be start setting our answers bit, and those bits we will be setting which are corresponding to num1 set bits, and those will be starting from MSB side. And if our bit count is exhausted in setting all those, then that we will be returning as our answer. But if that is not the case, if still there are some bits remaining, so now we will be starting from the LSB side, and we will be checking that what is the first bit which is unset, and then we will be setting that. So this whole now we are required to do in our coding part. So this is what we will be doing. So now before starting the coding part, let me introduce you something about Newton School. So basically Newton School is starting with some of the coding competition about which you can figure out for the link in the description below, and you can check everything about the same in that link, and you can participate for the same. And after participation, if you are the top performer, then you will be getting some exciting prizes. So that would be much good for you, right? So you can check for that in the description. And yeah, as I've explained everything, you could start coding for the same as well by pausing this video. And after that, then you can unpause and check that how we are required to do the coding. Now, before starting for the coding part, here you can check that what is the time complexity and the space complexity. So the thing is that the time complexity would be basically first we are checking for the first we will be going for checking number of bits, then again setting the bits, and then again setting the bits. So it will be like this. So time complexity would be order of one only, and the space complexity. Basically, we are not storing anything anywhere. So that's why space complexity would also be order of one. So in short, everything would be in order of one only. Time complexity and space complexity. So that's the whole scenario here. So now let us go ahead with the coding part for the same. So here's the coding. First thing is that if both of them are equal, then we will be directly returning the number, right? And at the starting, we are taking the count 2. Now, first thing is that we are checking that how many bits are being set. So this is how I'd already explained you in one of my video that how we check for the set bits. So this is what we are doing. Whenever a bit is set, then we are increasing the count of count 2. Here, just initializing the answer. And then here we are checking. Basically, here we are setting from the MSD side. So that's why we are starting from 31 and going till 0. And here, if a num1 is basically set, then at that point, we will be setting that bit of our answer and decreasing our count. And if at any point our count 2 becomes equal to 0, then we will be breaking out from that point, and that would be basically a required answer. So that's the thing. And if somehow our count 2 hasn't been reached, right? So at that point, we will be now setting our bits from LSB side. So that's why we will be starting from 0 and going till 32. And then here we will be checking that if at that moment our bit is unset. So what we will be doing is we will be setting that particular bit by this operation and decreasing our count. And if at any point our count 2 becomes equals to 0, then in that moment we will be returning our answer. So this is thing which is required to be done in this particular question. As you can clearly see, one loop is this 32 size, other loop is this 32 size, and other loop is this 32 size. So overall time complexity is basically order of 32 only, that is order of 1. And even we are not storing anything, so that's why the space complexity is also order of 1. So this was all for this particular question. Hope you like the explanation. And if you like the explanation, please do like and subscribe to my channel. And if you have any doubt, you could comment that down. So this was all for today. Thank you.